Hello, I'm Darren Jackal. I'm in my studio. I talk about product development, design, and mountaineering. Welcome to another edition of Experimental Design Discourse and Disclosure. In the past few episodes, I've been using a lighting project to discuss a variety of different design methods or processes, and I'm going to continue that today. I just want you to remember that this was a project that started off as one of many design projects for a nightclub, and that the wall sconce was really nothing to write home about, but it did start in me an interest in lighting. I had no real intentions of going into production with such a product, but because this idea was seen by someone who was interested in it and ultimately gave me some money to develop it, I wound up going down that pathway. Now, if this didn't happen, I probably would have just abandoned this at some point. I want to use this example to discuss now the production side of things. Going into production, I want to use the idea of effective dimensionality to really keep the complexity of the project to a minimum. I want to use design methods that will have minimum amounts of parts. I want those parts to be simple to produce, but I want to imbue those components with more than just simple matter-of-fact design things. I want to look for opportunities to provide what we would call more objective concinnity. All right, I'm just going to talk about some of the production issues I had, starting with the lampshade itself. This is one of the last ones from my initial run, and this is polycarbonate aircraft lighting white 060. Now, it took me a while to find this, but I did, and it provided me with a lot of the characteristics that I liked. It diffused the light well. It has memory in terms of when I apply force to it, and it wants to return to its original shape. So that gave me some of the properties I wanted in this. Now, the problem with it is, if you can see these cracks in here, is that what they put in this lens to make it diffuse the light actually burns. So I didn't have water jet at the time. So what I was having to do, because I couldn't laser cut it and I couldn't flame polish it, I was routering these with the manual router on a jig, and then I was polishing them on a polishing wheel. But as you can see, there was about a bunch of micro fractures that occurred, and I didn't know this at the time, but after a while they all started to craze and crack. I was able to rectify that with this version. This is also a polycarbonate. I was able to water jet cut this, so there was no micro fractures introduced. Now, there's some things here that I want to just show. The fact that these corners are not quite 90 degrees anymore. I originally wanted them to be 90 degrees, and we'll see how a mistake led to that. You'll see here that I have a hierarchy, or these two horizontal components being top and then hierarchy, where I do not violate them. However, this was never developed satisfactorily. It's quite awkward and not very well addressed. So finally, when I did this version, I allowed myself to break that convention of the hierarchy and then created a new dominance where this vertical element now takes over in the hierarchy and allows me to establish a composition that I think is much more appealing. We'll go out to the workshop and I'll show you the mistake that led to these overbends, and we'll look at how this visual language of basically lines in space and planes in space combined with forces, and how I wanted to maintain that visual language when I was working on the base. We'll look at this in more detail in a bit. This is the tooling I created to make the vertical frame element, the thing that is supposed to be the paperclip in my original Partee model. Anyways, I thought originally I was going to bend them into 90-degree bends at the top, but what happened was I overcut my form, and you need to overcut it. If you want 90, you need to go beyond because of spring back. So anyways, What happened was I went beyond and didn't get the spring back I wanted, and that left me with my uprights angled in. Now this was a mistake, but it was a fortuitous mistake because it gave me a couple of things. It was sort of squeezing the lenses, and it also, when I straightened out the verticals throughout the length at the bottom, it gave me this very gentle inward-outward curve that I found to be quite graceful. And so this was an additional piece of objective information, you could call it objective concinnity, that was able to hook the individual and engage them a little more. Now, you don't want to overpower people, and we'll see that there are some elements of the original lamp that were a little difficult for people, and so those changed too. But this is one of the things that I want to point out. Other thing is that my first run, the steel I was able to acquire was of really poor quality, and the surface was really bad. And so that was another part of my quality control, quality assurance aspects that was really disappointing. When it comes to the production side of things, you want to maximize part counts out of your available materials. So you can see this is the original lens or shade. It's made out of polycarbonate. I was able to get those in 4x8 sheets. And so this is roughly a foot by a foot, so I can get the maximum number of parts out of a single sheet of material. The steel I was using, square, cold rolled, I was getting that in random 12-foot lengths, so that combined with the dimensions of how much I needed for the cross piece and how much I needed for my jigging on the other end, that left me with the maximum height I could go. There are certain things that are just going to be dictated by your materials. This is how you would do it. This is be bolted down to obviously a large bench, and this thing is two-sided. I pop this off and put it on the other side over here, pin it down and bend both sides in one shot. They would be overbent, and then I would straighten them out in the jig I have here. So this is the welding jig, and you can see that this long curve I get because of the overbends. While I'm out here, I just want to talk quickly about the base of the lamp, which uses the same visual language. These two planes, upper and lower plane, combined with these rods, which are simply one-dimensional type of functional dimension elements. And the problem with this is that it's kind of soft and it can be kinked. So I did make some out of aluminum that I learned quite quickly were just not strong enough, especially if you've got a young kid who decides they want to step on this. And so I went to the stainless steel versions, which are here. Now this is the tool that I made to create what are, essentially these roll hinge kind of things. I'm not even sure what the term is for them. Anyways, I didn't have a tool in the shop that I could make those with, so I made this tool to do that. I wanted to control the means of production. Now this took a little while to figure out, and I went through a variety of different iterations on how to basically terminate this object to the ground. Where I found inspiration was in the work I was doing from footwear and my research into how the mechanics of the foot work. If we take a look at this foot model here, you can see that the structure of the foot, whereas we may refer to it as an arch, acts more like a curved beam in some instances or as a truss in other instances. So the key to understanding it is that the two portions of the arch, the rear foot and the forefoot in contact with the ground, are supported by soft structures underneath. And this in case is the plantar fascia or plantar ponderosa. And this got me thinking about how to finish off the lamp face. And so that's when I made these things. This would be just two thin plain pieces, and again two sort of single dimension lines, and they simply pin together. And again, through the use of force, we create an object that has a little more objective information and objective vicinity. So you can see that this is a tension member, an arced upper member, and the forces are being held together by these two pins, much like the other portion of the lamp, where the vertical uprights are sort of providing the resistance for the polycarbonate planes to push against and hold him in. The last part of this is the piece that fits in between here, and that's this component here as part of the lower part of the frame. So this is like, I think, an inch or an inch and a quarter piece of plate steel, and it's welded between the two uprights. And once this is all sandwiched and fastened together, it creates a very stable structure. I'm going to wrap up this episode at this point. There might be one more episode where I talk a little bit more about the fine details. But again, this is just an example of how you can iterate yourself to potentially innovation. I'm not sure if this lamp could be considered innovative. From a popsicle bomb and a paperclip and understanding of the mechanics of the foot, I've created a lamp that is ultimately a failure. So anyways, I'm Darren Jackal. I'm in my studio. This is Experimental Design, Discourse, and Disclosure. Hope to see you again soon.